So let's begin with the second part of the law. So it tells that the incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. So you guys understand what is incident, normal, and reflected ray. Here is what confuses many. All lie in the same plane. What does this mean? Well, to make you guys understand this, I'll take up a flat table. And on this, I want to place a cardboard, a hard cardboard, which too is flat. I can place it this way, or I can place a cardboard making an angle of, right? Not a good diagram actually, just a second. Making an angle of, so this is below the table, right? You can think of that as a shadow. So this is making an angle of, say this is around, it looks like 50 degree. Okay, so you guys can imagine, right? This is the table and that's your cardboard. I can keep the cardboard this way also, wherein it's one of the vertex is just touching the table. Say I'm able to balance it somehow and I'm able to place it this way. So what the law tells is, remember all these are plain flat things. If I happen to have an incident ray, right, in one of this plane, the reflected ray will be in the same plane. So if in this case we have an incident ray like this, the reflected ray will be something like this. It will be in the same plane. Here too, the incident ray and the reflected ray will be in the same plane. Not only that, even the normal. Okay, in each case, the normal too will be in the same plane. Here too, it will be in the same plane, and here too, it will be in the same plane. In all of these three cases, all the three lines are in the same plane. Okay, for a given scenario, they are in the same plane. So let me show you practically what I'm talking about so that you have a better understanding. So the video has a plane, right? I'm showing a plane. So that's a plane. Now I have incident ray and reflected ray. So example one, right? It's very clear. The incident ray, reflected ray, and if you imagine a normal, they are in the same plane. All of them are in the same plane. Okay, remember the orientation of the plane can be anyhow. So here I've tilted it altogether to the right. So it's around 60 degree, I guess. 70 degree, yeah. So here too you can see all of them are in the same plane. Incident ray, reflected ray, and the normal. Now moving on to example 3. So, okay, this is your example 3. So here too it's very clear. Incident ray, reflected ray, normal, all of them are in the same plane. Does that help? I hope so. So example 3 is over here. I've taken a screenshot. So it's clear that we have the incident ray, reflected ray, and the normal to be in this plane, which is not parallel to your horizontal. Generally, people always think of it being flat. Yeah, it's flat, but it need not be flat always to the ground. It need not be parallel to the ground all the time. Okay, so that's the whole point of the third law. The usage of this is not obvious as of in your grade, but yes, in future you will understand what is the use of this. Okay, so please note down pretty much everything on the screen.